Hello all, I have discussed about computer languages in this video, and in order to keep the video short, I have spoken a little bit faster. And if you find it really too faster to understand what I have spoken in the video, then you can reduce the playback speed in the settings below. Hello all, in this video I will be introducing you to computer languages, its advantages and how computer languages got evolved. So before getting into computer languages, let me quickly ask you a question in general. What do you mean by a language? A language is a medium required to communicate between two different individuals or two different human beings to express their views and opinions. Say for example, if this lady has to express her views or opinions or thoughts about a particular topic with this gentleman, and if this gentleman has to respond back to her on her opinions and views, then in between them they need a medium, and that medium is called as a language. Therefore, a language is a medium required to communicate between two different individuals or human beings to express their views or opinions on a particular topic. Right? So throughout the globe, there are several such human languages used by people to communicate between each other, and some of the examples include English, Hindi, Kannada, Malayalam, Tamil, Telugu, French, and so on and so forth. Okay, now having said this, then what do you mean by a computer language? A language used by a human being to communicate with a computer is called as a computer language. I will repeat, a language used by a human being to communicate with a computer is called as a computer language. Now when I say this, you might ask me back this question, why should human beings communicate with a computer, or why should human beings talk to a computer, right? The question is quite obvious, interesting, and the answer is also very simple. There are certain mathematical and logical operations that are beyond the capacity of human brain to process and give us the desired output in less amount of time, and that is when we need a computer. Say for example, if suppose I ask a normal person with little bit of mathematical knowledge the result for 5 factorial, then he might be in a position to give me the answer immediately, say 120. Whereas if I ask the same person what is the value of 200 factorial, then he may not be able to give me the answer immediately. The reason is it's a complex operation, and to perform such complex operation you need the help of a computer. And if you need the help of a computer, you will have to communicate with a computer. And if you wish to communicate with a computer, you will have to communicate with a computer only in a language that the computer understands. Right? Now having said this, which is that language that the computer can understand? Right? The only language that the computer can understand is the binary language made up of zeros and ones. Right? So binary language or machine level language is a language which is nothing but a series of bit pattern made up of zeros and ones, and if you wish to communicate with the CPU, you have to talk only in terms of zeros and ones. Now imagine, is it really possible by human beings to talk to the CPU in terms of zeros and ones? Right? Absolutely not. It is not possible. It is highly impossible to talk to computers in zeros and ones, right? That is the reason CPU manufacturers came up with another language called as the assembly language, right? Now, what is this assembly language? Assembly language are nothing but a series of instructions, or specifically CPU instructions, okay, which are made up of English. As you can see over here, you can find few instructions called as push, okay, move and add, move, pop, ret and all that, correct? So if suppose you wanted to perform certain operations, okay, you want some operations to be done by the CPU, you had to write assembly instructions, group it together and give it to the computer or give it to the CPU, so that CPU will understand and process the desired output. Now you might ask me this question, when computers can only understand zeros and ones, okay, how can you write an assembly code and make the computer understand, isn't it, right? So when CPU manufacturers were coming up with this assembly language, they also came up with a tool called as assembler, right, whose duty was to convert your assembly code into binary code, so that as programmers you need not actually worry about it, right? Now, why did CPU manufacturers come up with assembly language? Very simple. As I told you earlier, binary languages was very difficult for human beings to use to talk to the computer, and that is the reason they came up with assembly language, which contained specific CPU instructions which look like English. So when you have such kind of language which is a mixture of few English and few numbers, then the CPU manufacturers thought it would be easy for programmers to learn, understand, read and implement. Correct? But assembly language came up with its own set of problems. Now, what are those problems? I classify that into two set of problems. The first set of problems was that you had to memorize a series of instructions. Along with it, you had to deal with memory addresses, you had to deal with CPU registers, you had to deal with offsets. Okay, so it means you had to know details about the CPU to actually code using assembly language. This was one of the problem. And the second problem was that, a major problem was that, okay, in the market there were hundreds of CPUs, okay, say Intel, Pentium, okay, that is Pentium belonging to Intel, okay, ARM processors, PPC processors, okay, Spark processors and all that. So the problem with so many CPUs was that, okay, you had to memorize assembly instructions belonging to each and every CPUs, right? So Pentium people came up with their own assembly instructions, ARM people came up with their own assembly instructions, and PPC people came up with their own instructions, right? So if suppose you wanted to write a code to find out the GCD of two numbers, then the assembly code for that was different on a Pentium CPU, because you had to make use of assembly instructions belonging to Pentium. And if you wanted to find the GCD of two numbers on a ARM CPU, then again you had to rewrite the complete code using ARM's CPU instructions. Similarly, if you wanted to find out the GCD of two numbers on PPC CPU, then you had to use, okay, PPC's instructions to generate the assembly code, right? And each one came up with their own assembler which used to convert that assembly code into binary code, and this became very, very problematic. That is, in simple words, assembly language was CPU specific. It was completely dependent on the CPU, and it became very difficult for the programmers to memorize or understand and implement using multiple CPU languages, which was again a practical problem. So to overcome this problem, okay, so programmers came up with something called as a programming language, which is completely CPU independent. It means you had to learn only a language, okay, and you didn't had to actually memorize some CPU instructions at all. The one that you can see on the screen is an example of a C program, okay, and this is a high level language or a programming language which is very closest to a human language. The only thing that you got to do was to learn this language and write the logic for the problem that you wish to solve, and use another tool called as a compiler, which would do the necessary task of converting this high level language into the machine language that the CPU would understand. Therefore, you had no worries about how to write code for a specific CPU. The compiler used to take care of that thing. Whereas in assembly code, you had to worry for each and every CPU. You had to write code for different CPUs, right, to solve a single problem. Whereas in a high level language or in a programming languages like C or C++ or Java, you write the code and you use the compiler to convert your actual high level source code, that is English like looking source code, into your binary code. The compiler had inbuilt actual compiler and an assembler which would actually convert that into a specific CPU. So the advantage of your high level language or programming language is that it was completely CPU independent. You had nothing to worry about what CPU to code for or which CPU to code for, because the compiler used to do that particular work for you, right? So I will show you that in the form of picture over here, right? So you write the high level code, that is source code. So the examples could be C, C++ or Java or whatever it might be, okay? These are all high level languages, and you will basically use a compiler who will actually do the job of converting that into a specific assembly code, and then you might make use of a specific assembler there, okay? The compiler might have inbuilt assembler which will do the job of converting that into a specific binary code related to that particular processors. In this way, okay, high level language was very useful, and it became very handy for programmers to code, right? So that is one of the biggest advantage of having high level languages. Therefore, we learned three kinds of computer languages. One being the binary language, which is the most closest to the CPU, okay? The CPU can only understand zeros and ones, okay? And on top of it, you had assembly language, okay, which are nothing but CPU instructions written in English, okay? But the disadvantage of assembly language was that programmers had to learn multiple assembly languages for multiple CPUs, okay? And this problem was basically solved by programming languages, which was completely high level English like looking languages, where you had nothing to worry about the inbuilt CPU, because a tool called as compiler used to take care of converting this high level language into low level language, right? Now putting everything together, okay, so you can classify your computer languages into three different languages. One is high level language, second one is middle level language, and third one is low level language. Okay, where high level language can also be called as a programming language or a source code. Okay, and the middle level language I call it as an assembly code, and low level language is nothing but the binary code. Okay, so if I put these three things into a picture, it would look like this, where okay, hardware is nothing but the CPU, which will do the required operation for us, which will help us doing some mathematical and logical operations. Okay, on top of it, the closest language that the CPU will understand is the machine language, which is nothing but zeros and ones, right? And then on top of it, we have assembly instructions. Okay, so few specific instructions written in English. Okay, I call it as CPU instructions. Okay, but yeah, the problem that we faced, as I said earlier, was there were multiple CPUs and we had to learn multiple assembly languages. So to overcome that problem, programmers came up with something called as high level languages. Examples include C, C++, Java, okay, and Fortran, Pascal, and all such kind of things, where the advantage was that you had nothing to worry about the CPU, that is the below level CPU, which used to be taken care by the required compilers, okay, of these particular languages, right? And yeah, so when you classify this, okay, basically most of them classify this into high level language and low level language. The reason being that, okay, today when you're actually coding using C++ or Java kind of languages, you had nothing to worry about assembly or machine level language, and people started calling these two languages together as low level language, and the one that you write in English like language, you call it as high level language, right? So hope you understood the different classifications of computer languages. Okay, hope you enjoyed, hope you learned some really new stuff. Okay, so meet you in the next video. Until then, take care, bye. Thank you so much.